Unfortunately, medicine is so out of date that if I asked you what the difference was between a voltage, power, and energy of a synapses, you may not actually have the answer to that. Matter of fact, you may not even know what voltage is necessarily. You call out synapses voltage. Voltage is also potential difference, but the best term is probably electromotive force. So now if I was to tell you that I'm standing on the floor and the floor was 10,000 volts, would you understand that I'd be alive? Similar to a bird on a power line? And yet, for whatever reason, a lot of people still die, putting up power lines. So how does that work? The reason is that electromotive force is basically just like diffusion. That's all it really is. When you have a buildup of charges over here, they go through diffusion. So if you were to go jump your car, right, and you were to plug just the red wire or just the black wire, would it work? No, it requires a loop. Well, you couldn't just have endless diffusion, right? And so what happens is in a circuit, you have a loop. The loop that exists in our body, the only actual circuit, is the cardiovascular system. Current times resistance is how you get voltage, potential difference, electromotive force. You call it a synapses. You have to understand that resistance is something that is natural amongst all things, right? And so when you have a circuit, the current in that circuit is the same all in the circuit. And so now, how are you getting random synapses measurements or voltages? Well, what happens is you have a variable resistance. So understand, when you're measuring synapses, what you're getting is the current hitting a peak in resistance. And so imagine you had two resistors, right? Just a little 1 ohm and then you had a 10 ohm. And you put 1 amp through that. What's going to happen is you're going to get 1 volt here, you're going to get 10 volts here. And so when you're measuring and you're like, boom, there's the synapses, that is simply the spike in resistance because the current going through the circuit is constant. So now imagine a scenario where you've got this plexus here. Now imagine you have this little silly guy figure right here, right? And you have 5 volts here and you had 0 volts here. You understand how this is actually an impossible scenario. If you had 5 volts here, you would have 5 volts there. This would be the only way that this would work. The only way you could have 5 volts is if you split them in half. So when you're acquisitioning potential differences, understand that when you use 2 prongs, inside there is a very, very high resistor value. It's known. And so now when you acquisition across them, you're going to have a certain current going through that resistor, and you're going to be able to get a measurement based on that. Now that you understand that voltage is current times resistance, and the current is constant, but the resistance changes, well, where is the current, right? Current is the flow of charged particles. So now, the flow of charged particles requires there to be a potential difference, right? Basically speaking, there has to be some difference between the values for there to be diffusion. So now, the difference between a wire, right? Anything that's metal that has these shared electrons, well, the electrons can then move their way through the crystal lattice. And because we know that an atom has its own, van der Waals radius, basically they're going to press against them, and it's basically a pressure kind of a thing. And so if you look at the actual flow of electrons in a wire, it's something like centimeters over like a long period of time. It takes a while. So about the difference in our body is, right? So how do we get a flow of charged particles? This is done via molecules. Now, so assume that there are molecules moving around in the body. How is that happening? It's happening via the fluid. So you understand that if you were to drop a toaster in your tub with you would fry. That's because the water, right, is allowing for the movement of those molecules. So the one last thing, right? Understanding that if you were to push electrons through a solid, like let's say you were gonna get all right. So we're just seeing that basically the only reason why there's even a resistance and it's not basically like infinity on my skin is because of the moisture level. Touch my knee with it, my thumb. All right. Jeez, come on, me. Seen this before, right? You've heard that before too, right? Now you have an understanding as to why that's happening. Now, adjustment here. Now watch this. Whoa, what's that? So now that you kind of understand it, let's look at this baseline here. The reason why it starts climbing is because as it starts to get closer, the relative resistance with respect to distance, right? The distance is closing. So then what happens is it climbs up. Now the potential has gone back down to baseline. Why is it baseline? Because like we said, it's potential difference, it's diffusion. And because the potential here is the same as there, we're at baseline. So then now what we have here is that it's bleeding through the line, right? You see it starting to create a negative potential. That's just with respect to your measurement. And then what happens is you guys miss this point here because of how fast it happens. Basically, as the fluid starts to fill up, at the moment in which the fluid actually makes contact is when you get to the spike in potential, right? Because your actual heart doesn't move at that rate. You don't have instant acceleration of a mass. Oh, it's still gone. All right, cool. Now, I know you want electricity to go through this, but consider this. Imagine if I pushed water up this end here. Would you assume how much would come through here or there, or what if I pushed water just through here? What's crazier is when you consider the fact that the artery wraps its way straight through there, right? So now when it pulses, and there's going to be certain things that you're going to detect. I don't want to get too much into it. Appreciate any likes, shares, and subscriptions. It really helps with the channel. And like I said, if you have any comments, please post them.